Uh, Hello everyone. My name is Ostap Kostiuk. I was born in Lviv and now live in Kiev. So I play music, I perform, make musical instruments, program microcontrollers, and do different kind of stuff. I'm a self-taught person, so all I've learned is basically mostly from the internet. So today, the topic of our lecture is I will share my screen for you. Entry into electronics, the sound of frying chips. So. I started. Can you hear me? Because I don't hear, no, can't hear any sound, and I'm not sure if it's still working. Can you just write something to the chat or say something so I knew that everything is working?
Yeah, it's good.
Oh, thank you. It's okay. So I started without knowing any theory and some specific stuff. I just started from practice, and I think that a nice way to start to get into electronics is circuit bending. So what is circuit bending? This is basically it's chance-based customization. This means that you just open your device and connect randomly points on the circuit board. And depending on the result, you just keep doing this and you can get different sounds. So this can be toys, but the point is this low voltage or battery powered devices. So it's not plugged to 220 volts because this may kill you. And this is safe. So it was invented this technique, Reed Gazawa, in 60s. He invented this technique randomly. His toy amplifier started to produce sounds that were similar to the expensive synthesizers. So he just didn't have money and to buy the synthesizers because it's 60s and they're big and expensive. Analog stuff, and he decided he invented this technique called circuit bending and started experimenting this, and he is like officially, unofficially the father of circuit bending. So I will show you some of my devices and explain how they work. This is, we will start from the Furby. The Furby was released in 1998 in Japan by Tiger Electronics. And this is how it looks and sounds like. The interesting part about this toy is that this toy is capable of speech synthesis. It has a chip that allows you to synthesize speech. And this is how it looks like.
Sleepy, all gone. Me, boo. Maybe me, sick. Achoo. Aha. You.
So this is a customized toy, and I will show you something. These two buttons, they are connected to the buttons that were on this toy. You can rub his belly, you can scratch his back. There is a microphone. Fergus is capable of hearing some sounds, then reproducing it through this speech synthesis. It even has a personality that can develop somehow. These contacts are connected directly to this chip that is making this speech synthesis. And just connecting these pads, I was doing it with a coin, or you can find other ways of doing it. You can alter this algorithm. So basically, if in the context of algorithms, circuit bending is kind of a prepared algorithm. For example, if you take different objects and put it between the strings of a piano, so this is a prepared piano. And this is a prepared toy, I would say. How to start this? You can go to a flea market and buy this cheap different toys. But I was not buying the random toys. I first Googled a lot and found out different information about them, and then I was buying them and then knew what can I expect, what can I do with this. For example, if you want to find a schematic for a toy or a synthesizer or something, you can Google manual, and you will get the manual, the regular manual for a device, or you can Google a service manual. When you Google service manual, you can get the schematic of your device. For example, this is a service manual for Groovebox Korg Electroacoustic. This is the service manual for Japanese synthesizer Yamaha PSS. It was interesting for me because there is a chip that can do FM synthesis, and all we love FM synthesis. It's capable of producing different great sounds, and this is how it sounds. I will show you. So this is Yamaha.
Pas de bureau, c'est là mon bureau. Je vais écouter comme ça. So it sounds like FM synthesis. You can hear, you can see this box.
over here, it has some switches, fixed switches and momentary switches. It means that when I press this button and release, it's just connecting to points when I press it, and when I release, so these points are no longer connected. How does it work? When you open your devices, you can find different chips there. So, for example, there is a ROM and a RAM chip. ROM, this is read-only memory. RAM, this is random access memory. So these chips are used for storing sounds, presets, and all information that can be interesting to mess around with. So circuit bending is just connecting the points of this chip together, and you hear the result and continue. So you can find different places where the potential is hidden. So this is ROM chip. Also, this is a CPU. CPU looks like a big chip. I think it should be the biggest on the board when you open it. So it's easy to find. When you mess with ROM chips, it's safe. But with the CPU, you can damage your device and it will no longer work. So in circuit bending, this is a common practice that you fry chips and they don't work after that. So there's a great chance you can end up with nothing. But this shouldn't be a disappointment. You should just learn from this and continue. So this chip with the sticker and with numbers, this is OS, operation system, and no interest in there, no sounds. You should not mess with them because you will definitely kill your device. So the heart, so the CPU you can consider as the brain and of your device, and the heart of your device is the crystal. The crystal, this is something similar to the crystal that you have in your clock, a quartz crystal. It oscillates in toys. I found oscillations like the range between 4 megahertz, 30 megahertz, something like this. And the interesting thing is that you can change this crystal and put your own one, your own heart for the synthesizer. It looks like this chip. It's called LTC 1799. It's easy to find on the internet. You can buy it and alter the sound of your synthesizer, toy device, anything. So the interesting thing is that when you change this heart rate, the rate of the clock, you can change the pitch, you can change the tempo, you see that the display can be like dimmer. You find that when you push a button, you hear the effects with the delay, because if you make the rate of your oscillator lower. So I will show you the next thing is the drum machine Alesis SR16, where different techniques are combined. So for example, this is this wires attached to pieces of metal are attached to the CPU, and sometimes it can play by itself. This plate, this is all of these contacts are connected to the ROM chips, where the samples are stored, and this is this crystal that I made with this chip LTC that is controlling the pitch of the samples. Now you hear how it sounds like. The interesting fact that sometimes I don't know how to make it again, but it just occurs and happens randomly. Sometimes this box is like a Termin box. you can play with your hand. In this video, you can see this little wires, and you can use them on this patch bay to make connections like in a modular synthesizers. But this is a really efficient and cheap way to do this, because it takes not much space on your device, and they are small and cheap. So the point is that these devices are unexpected, so you should find just your way how to deal with them, because it's not very easy to implement this, for example, in your concert, because it can be not ready to play what you want and what you're willing to. So maybe you can record this and then use it as sample base, or if you like this unexpected behavior, maybe it's like the point of your play of your concert. So I consider this chaotic and noise instruments very pleasant to work with, and giving you always some unexpected results. So it's a long disguise. It's just a process of discoveries, and the process of playing with these instruments will give you, with time, more. You will just adapt to it and learn how to play it like a regular instrument. But this takes a lot of time, a lot of different engineering, and you need to work with interface. Because for me, it's interesting how you are connected to this machine, how you interact with it. This is like the topic of my investigations in this field. I also wanted to show you different algorithms that they use to produce this chaotic and noise random behavior. So I found a very interesting Dutch inventor. His name is Rob Hordijk. He makes modular synthesizers, and this is his creation. So he was inspired by a Dutch composer, Jan Borman, and Jan Borman was using filtered sound from noise in his compositions. And Rob Hordyke invented interesting algorithm. It's called Wrangler. You can read about it if you Google this, the Blippo box, a chaotic electronic music instrument band by design. You can find an article where Rob describes in depth how it works. I will show you in a minute how it works. So the point is that on a synthesizer, on a modular synthesizer, for example, you got this noise where you patch, and you got white noise. So white noise is basically a combination of a lot of simple sounds, sine waves with different pitches, fixed pitches, different amplitudes, and there are all possible pitches and amplitudes. And there is a theory that in noise is hidden every possible sound. It's a theory. So he takes the basic sound sine wave, the complex sound noise, and his interest is in doing something in between. That's how he invented this algorithm called Wrangler. Wrangler, this is the architecture of the Blippo box. You can see two oscillators. There you go, a lot of feedback here. Another, his instrument banding is a little simpler, but the point is the same. The architecture is the same, just a little simpler. So two oscillators come into a Wrangler, then there's the feedback, the voltage comes back, and it is capable of producing patterns. So I will show you these patterns, and then I'll show you how it works.
Остап, будь ласка, включи розширення екрану, нема нічого.
А, серйозно? Sorry. So you haven't seen the previous slides? Have you seen this one? No?
No, we haven't seen.
Ah, sorry. So this is the guy I was talking about, Rob Hordyke. This is his creation. This is his instruments, Blippo box. You can Google this name and find the article. This is the architecture of the Blippo box. This is a simpler version, Banjoline, that you will see in a video. So I made this Banjoline, I made it with two voices. So this synthesizer has two voices. This is the first voice. the second voice, and this is a crossfader in between. I can make it you can make it improvise, or you can make a loop with the 8-step or 16-step. This matrix is capable of this. By patching, you're capable to add modulations, and the range of the instruments is growing very much with all of this. So how it's based on the Wrangler, the heart of this synthesizer is based on a shift register. Shift registers are chips that are capable of taking serial data and transferring to parallel data, or parallel to serial. So how it works? This is a source. It's got two inputs, source and clock. So I will take the noise just for demonstrational purposes. So this is the input, this is the clock. When it gets transition from 0 to 1, it samples the input and then shifts it to the right. You can see how it shifts. You get a value and it shifts to the right. But in the Wrangler, there is a rectangle oscillator, and rectangle oscillator is basically 0 or 1. So it's a binary. Then it takes the output. It's the last 3 bits can be 8 different combinations. And these combinations, you just could see these patterns on the video I showed you. One, two, three, 4, 5, 6, 7, and 8. So it's capable of producing patterns, very interesting patterns. And I like to play with it and use it in my practices. So this is like we're going from noise to order. If you want this chaotic behaviors, noise, and unexpected results, this is the place where you may find something interesting. But if you want something that is not so random, there are chips that you can program. You can put there your own program code. They are called microcontrollers, and they are capable of doing a lot of different stuff. For example, you can use Wi-Fi modules. You can even some microcontrollers have built-in Wi-Fi, Bluetooth, different stuff. You can use motors. You can use displays, LCD displays, 7-segment display, a buzzer, a little speaker, flash memory. You can connect different microcontrollers, keyboards, piezo elements, different modules. This one looks like I don't know, smoke detector. I don't know what is this. Buttons and all this kind of stuff. The point where you can start experimenting with it, I started from a microcontroller called Arduino. A lot of people don't like Arduinos because they are slow and they have not much memory. But this is a great place to start because there's a lot of information on the internet, big community, and they are easy to program, really easy. You can find libraries. It's not so difficult to start. So this is a place where you connect it by a USB. This is you can plug power. This is the clock that I was talking about. This clock is 16 megahertz. This is the chip that is a microcontroller. This is the brain of the of this board. And you can have 6 analog inputs. This is analog to digital converters. They are 8-bit. It has digital inputs or outputs. You can use them as input and outputs. But in analog, for example, it's 8-bit, so it's 1024 different values. And here, these values are only 0 or 1. Also, it is capable of doing pulse width modulations. So, what can you do with these microcontrollers? Just to give you an example. I will show videos from YouTube. I hope they will run okay. This is, I will show you and then I will tell you. So we found this piece of piano in the how's it called? It's called barn or a shed, a place where you keep domestic animals. And bring it to garage. Started experimenting with this, and later on I made a concert, but not with this piano, with the other one. There were a lot of these motors. These motors are called solenoids. Basically, it's a piece of metal in the coil, and when there is you bring power to the coil, there is electromagnetic field that pushes this metal and it hits the string. So this is the principle of this instrument. You can control it with in this video it was controlled from Maximus P, from a keyboard of a computer, was sending information to this solenoid. Another thing I will show you, this is a project for okay, I will show you this was a project for exhibition Ukraine Wow. It was on in Kyiv in a railway station, central railway station. Interesting fact is that these exhibitions in 4 months there were more than 300,000 of people visited it. The point of this project is that you have a Kinect camera that is this is the Kinect camera. It can find that I'm a human and give a projection. This is like my screen. This is the screen of these points, and it's just matching and showing this on the screen. The screen is very low resolution screen, and you will understand in a minute how it works. So this is what you can see on the display of computer, and this is what you can see in what you could see on the exhibition. I should say that this idea was not mine. I was just programming the stuff and making the next patch. The idea is the idea was it was inspired by Daniel Roth, a New York-based artist. If you find his works, he's got the similar principles, but his resolution is much bigger than you saw in my video. So the effect is much better. The next piece is a piece we made with Яна Шляbanska, Tatiana Хорошун. They were so this to every piece of wood here is connected piezo element. This piezo element sends data to the microcontroller Arduino, and then Arduino is triggering different sounds. All the sounds were recorded in the wood, in the forests. These are just samples of sounds of trees processed and triggered by him. On video, I won't show you it till the end. I think you get the point. We get into the end. This is just, I will show you this video because at some point I was obsessed of doing a costume or a suit that was capable of transforming a movement into sound. So this is like the first test of chip. And you can see here the interesting thing that you don't need to solder, you don't need to, it's very easy to connect the stuff. Yeah, this is the chip, the accelerometer and the gyroscope. You just connect it to a microcontroller, connect it to the computer, and it's like, it's really easy. It takes minutes to do this. I can hear some sounds. This is like the basic stuff you can do with the microcontrollers. The last project that was presented yesterday, I guess this also was made with Jana Ślebańska. So this is a project, this is a phone that is hung on a wall in a public place. And it was dedicated to the composer, Ukrainian composer Boris Lyatoshinsky. And you can dial numbers of different years, and in this when you take this, I don't know how it's called. You can listen to his music every day at 12 o'clock. It rings, and if there will be a random person going nearby, it can answer the phone, and you will hear the voice of Boris Lyatoshinsky. Just to show you how it looks inside. So this is the ringing bell. This phone wasn't capable of ringing, so I made him a ringing bell. And you can see this is the board. This is just a programmer to connect your microprocessor to computer. This is a microprocessor. This is the MP3 player that can store information on a micro SD card. This is the clock, so it can ring at 12 o'clock every day, and this clock is working on a battery. It can work like for half a year or more, I don't know. And this is the stuff just to ring the bell. So it's pretty easy, not big, and also it's connected by these connectors. No very big, you know, you don't need to manufacture PCBs and do a lot of stuff. You can make it like for several hours if you want to. So these are just the things that are capable of doing with microcontrollers, and I wanted to show you that it's just the possibilities of technology. The way you will use it is, of course, your own decision. For me, for example, I started not from circuit bending. I started from Arduino, and I started in 2011 when I attended the concert of Marek Koloniewski in Club Cinema. It was organized by Quitno. This was the moment, the crucial moment, the game-changing moment for me when I started doing these things, and I was so excited with the concert that the next week I bought an Arduino microcontroller, and this is how my journey began. Also, the next crucial moment was when I started attending the Media Art School. Our friend Jorge Kotopalski made the black box. There was lectures, hardware development, and I went there, and they just showed me how to do things with work, how can you make your PCBs, and all this dirty stuff you need to know to start doing this whole practices. So I have now an opportunity to say thank you very much for this experience. You can ask me some questions. Maybe it wasn't very understandable.
Thank you, Ostap. It was fantastic. This mosaic, this palette of a lot of possibility, and thank you very much for your working with composers, young composer like students, and I'm sure that with our project Pandemic Media Space, a lot composer also want to work with you and collaborate with you as engineer, like some.
Yes, I would be very pleased to do something together, because I like doing something with other people that always disciplines you and opens a lot of new experience.
Some questions,
So
please.
you can write it later in the chat. I will
Yes.
answer you if
And
you want.
now we have time for Eugen Vashchenko. Zhenya.
Hello, everyone.
Oh, yes.
I will use glasses because I have some lamp in front of me. So at first, I want to thank you, Ostap. You showed really amazing stuff. It's really inspired. I really inspired with your hardware design. Thank you. And I can say about my experience here. I'm working in the field of parametric media installation in public spaces. I use sound design. I use visual generative graphics, and also I work with parametric architecture and generating physical forms for public spaces. And also I make workshopping activity to teach my technologies, my experience, how to work with sound design, generative graphics, and physical forms. And now I will show step by step some works I did in solo working and as well in collaborations, and also some results of workshop activities. Let me show the screen. Here I can reflect my work like simultaneous vision of the sound, the visual matrix, and abstract physical forms. So first of all, it is connected in parametric media installation for public spaces. And also I generating a visual environment. It is a kind of virtual environment which could generate graphics, sounds based on the harmonies. Here on the picture, you can see the physical form, which is a result of generative algorithm called Voronoi pattern and Fermat spiral. It's a kind of sunflower algorithm connected with Voronoi algorithm. And then I just made production into the physical material. I just developed a kind of concrete material, and I did some matrix which was stoned into the physical material. It is just a frame from the visual, which could be kind of motion visual. And one of the frame of this visual is stoned into the physical material. This is another one work I worked with waveforms and parametric design of the form, and the form also is linked to the room with magnetic fields algorithm. And this is a kind of collaboration project with Light as A7 Light Studio, and we did parametric lighting system into the interior. And my task was to develop the parametric form for this object. I made some deep analysis of the room on the specific points, and I did a kind of algorithm which can generate lines of the magnetic field inside this room. And I just selected some special lines from this magnetic field based on the composition, and generated the form of this lighter from these lines. And then we just made drawings for the production and assembled this physical form. This is a kind of working environment. This is the points of magnetic field, and you can see different lines of this magnetic field inside the room. And together with architects of this space, we just made selection of this of the magnetic field we use to generate the object of the light. And once the magnetic field was chosen, we applied an algorithm which I developed in the Grasshopper 3D. And I just made some custom algorithm which can generate these frames, this structure of the reflectors for the light system. And we applied kind of sound harmony and kind of sound form to generate this form. Because one of my activity is to make a kind of translation of sound into the visuals, or visuals into the physical form, or I can even translate some visual picture into the sound composition. And it is very well translated. Now technologies are allowing to translate any kind of media to another kind of the media, and the harmony inside this media could be translated to another medias. So we can easy to work with harmonies to translate various medias to generate parametric installations. This is a kind of production. This is part of this lighter. We see the reflectors. We see some constructive elements which supports this reflection system. And here is the drawing which was generated with Grasshopper 3D and Rhinoceros. This is another one project based on generation of either surface from the mind wave. The project was shown in different museums, and the basic principle of this project was a kind of translation of the magnetic field inside the brain, which was analyzed with mind wave sensor, and the sensor translated this data of activity of the human mind. The program I developed translated this activity into the visuals, and it translated this activity into the sound. And then the visitor was situated inside this virtual environment of the museum, and generated these forms just with mind wave, and started to make a reflection into the mind. And when the visitor spends 10 minutes into this environment, he starts to collaborate with his own mind with this environment. And at first, when the visitor wears the mind wave sensor, it starts to randomly generating a kind of melodies. And when the visitor spent around 10 minutes into this space, the data started to be structurized, and we perceived some melody generation of some kind of harmonic melody when the brain started to be synchronized with this environment. This is a kind of snapshot how the visuals works. Just one frame. Let me show you the video of this process. The video I will show now is recorded from the previous research work which was done in Austria Institute of Media Archaeology.
So the name of the installation is Intersect. It's a kind of intersection in between of mind and reality it could produce, and in between reality it could analyze. When we switch on the sensor, it will produce the wave. Depends on your work or loudness of the field of brain, which is analyzed through the sensors. It produces the melody.
The sensor helmet, is it like developed for neuroscience or?
Sorry.
Yes, you need to help me. Okay.
This picture is directed to understand where are you in your brain wave. So this is moment of now, and also this. So this is the process of now, and you can.
So, okay. Just try if I'm saying something, if it's changing. It's really interesting because you can recognize it immediately. No?
When you move something, you also a lot of activity.
It's really interesting because normally it's so.
So at first, when the person wears the sensor, it starts randomly generating the melody, and after the person realized how it works, and she started to communicate with mind and sensor, and the visual started to play some more structured melody. And let me show you the video about the light system I showed before, how it works into the space. I just focusing in these 3 or 2 works. This is the result of the light system, also based on the wave. This is a kind of physical object which shows how the waveform is translated into the physical material, and they use it like functional object of lighting system. And it could work inside the interior, like the lighting system, as well. It could work like the art object kind of sculpture installation when the light is switched off. And if to work more with this object, it is possible to integrate the visual mapping with another one software called Max MSP Jitter. Let me show you. The next project is based on the real-time generative graphics, which generates abstract space into 3D space, and it generates real-time motion composition, which could used in different spaces. It could be used like building visual mapping. It could be used like just motion ball with projection. It could be also used like media drawing or media screen, which is a kind of art object inside the interior, and it could react onto the movement through the webcam. Once this visual synthesizer is developed, it could be running on different devices simultaneous, and it could produce a lot of variations of harmonic colors and virtual space, and it could be like artificial nature, maybe, or a kind of abstract space which possible to see a long time. Also, it could generate static graphics. But at first, it is just an application which generates visuals and sound in real time. Now I can show you how it works in real time. So it is generating just now with the sound. It is a kind of Max MSP Jitter based application. The application consists from several parts which could could be shown here. It is a kind of screen which shows the result, and a kind of screen which operates of settings of this result. We can switch different modes inside this application. We can change complexity of this form. It could be really complicated, depends on the system. It could be really low poly if the system is slow, and it could be running in various computers to generate it in real time. And also it reacts onto the activity of the webcam connected to the computer. And it generates sound processing, which is generating in real time. So this program, this kind of micro application, have no samples and no pre-recorded data. It generates all the visuals are generating in real time and generating the sound as well in real time. It has some user manual for the basic instruction how to work with this application. It has some concept notes about what it is and basic instruction and some links. In the front end of this application, we can change some settings. And also, I can show you what is inside this application. It is not so complicated, but there is some structure inside built with maximum spin jitter. So here we can see some objects which are connected one with each other, and for example, we can see how the visual is generating here. This object is a surf, is custom object which is kind of encapsulation of the microscheme inside. And if I double click them, I will see the structure I just developed to generate this graphic. It is a kind of BFG generators which are mixing each other. It generates some binary, just not really binary, but grayscale matrix, which is using to build 3D structure with is a surface algorithm. And once the structure is built, we can flow with 3D camera inside. We are flowing through the structure with 3D camera inside the OpenGL space. And the colors used into these visuals are a kind of harmonic colors palettes I generated from the book for the color harmony. And here we can also put the data from the camera here. But now it is not active because my camera is using for the translation. But if we connect the webcam here, the structure starts to make transformations in real time. It starts more live and abstract. So this application has two modes. The static mode is when the structure is generated and the camera is flowing through the structure. And another mode is when it is generated in real time each frame. I will show you the video how it works. And the sound is generating here.
Zhenya, I'm sorry, the sound is not enough. Little bit more of sound from Max. Can you?
How it is now? Oh.
Дуже тихо. Зараз мабуть недостатньо. Зараз добре.
Добре. Окей. Here is the sound synthesizer, which is really simple. It generates polyphonic additive synthesis and car plus so on. For example, we can see here we can see a number of pictures which are used to generate this polyphony and the real synthesizer has 5 voices. And it is recomposing in real time. You can make changes manual. For example, I can use really low or really high frequencies. Here I use 2 synthesizers. example, now I work with this one. And all the process is automated with the 3D structure. And here I also have a list of colors used to generate the color for this 3D form. The colors are not random colors. These colors are related into some harmonies. I just analyzed pictures to generate some special palettes and harmonic colors to apply into this structure. So when we combine all this data into one, when we combine colors, 3D form, and when it is connected to the harmonic sound, it starts to generate multi-level or multi-dimensional harmonic synthesizer, which could be exhibited, it could be perceived with visuals, with the sound, and it could also react onto the motion. And that's why it's possible to apply this synthesizer in various spaces, like various public spaces. To create a digital environment. Now I will show you the visual, how it works with the real-time webcam. Here we see now it is a static mode, and now it starts to react onto the webcam. During this video, it is various modes, and it is switching one by one. So it works something like this. And let me show the next project when I connected visual sound and the physical form into the one object. So it was made onto the platform of some festival, and it was realized with grasshopper and rhinoceros. I built the structure using the Voronoi algorithm and combined this structure. I assembled the structure into the physical material, and I combined this object with visual mapping and the sound design. The video demonstrates different stages of creation of this object. This is a process of assembling this object. This is a viewpoint from inside of this object. This is a screen which shows the grasshopper 3D environment where the object was generated with and this is the screen of Max MSP jitter software, which was used to create the visual mapping and the sound design. So once the object was assembled into the physical material, it was mapped with visuals, and it started also to react onto some activity around the space. And it is also possible, I think, it is possible to connect this object to any kind of sensors. For example, mind wave. It's possible to connect this object to different activities. It's kind of 3D sculpture, and sound sculpture, and visual. So that's how the parametric tools could work with media installations in public spaces. Let me show another one object which was developed for another one festival to make some kind of reconstruction of old space with something new.
Меня зовут Евгений Вashchenko, я делаю здесь инсталляцию. Сегодня мы видим то, как объект заполняет пространство. Оси наполняются 3D-объектом, который мы переносим из цифрового.
This is a kind of object we generated into 3D space, and then we made drawings to create this object into the physical material. And we made it together with a team who helped to realize this object into the short amount of time.
И саунд-дизайна. Олег Барановский, технический директор этого объекта. Также мы начинаем с ним коллаборировать по композиционной части. Объект почти готов, осталось настроить видеомаппинг и саунд-дизайн.
This object was used like kind of structurating object through the visual and through the form when it was applied into a kind of old room. The room started to be perceived like something new with this media object. So the object was combining the parametric design and visual mapping and sound design, and it started to work with space pretty well, and the visitors started to perceive this space through this object. So this is a kind of some video record of the static space with its 3D sculpture. This is pictures of the previous object I showed before. It is stages of how it was developed one by one. So the form was assembled from polystyrol material, which is really ecological type of plastic. It allows to make development of the physical form, but this object could be assembled from any kind of material which could be used with functionality. For example, it can be kind of media screen inside the interior, or it can be some kind of lighting system. Also, it could be maybe outside design or sculpture, which could be a kind of part of garden sculpture. So my task was just to create abstract form with harmonies inside the form, and this form could be applied into any kind of human activity in space. It could be functional, even it could be maybe the furniture design, because the parametric design is used inside the interior design as well with now modern architects. So my task just to work with composition and with abstract harmonies to connect various forms of harmonies to create something nice for the perception. So this is part of microscheme which was used to generate this object. And the stage before, we did some workshop to generate such forms into small scale. So we just made research with the group, and I did some study program of how to create such a kind of objects with most simple way. And in 4 days we generated this form with Grasshopper 3D. Then we generated drawings for the fabrication to create this object into the physical material. In the next day, we made development of micro application into another one software called Maximus P Jitter to create visual mapping for this object. And another one day we made the sound design for this object when the visual mapping reacts to the sound. And in the final day we combined this testing object into the one object. We combined this Voronoi diagram structure developed from the physical material. We combined this with visual mapping and sound design in real time, and it starts to produce some kind of abstract energy inside the interior. Let me show the video how it was worked after. So we made just a simple algorithm of visual mapping. The projection, just switching on and off each pixel of this abstract media screen. It's possible to call this object like a parametric screen when the pixels are not regular form but based on some natural structure of cells, which is generated with Voronoi pattern. And also each changes in the into the visual could be linked to the changes into the sound. Now the sound is just abstract, but it is generated in real time also. And if to think about the functionality of this object, it could be really functional inside the public interiors. Here it is just developed for the museum experiment, but if to work deeper inside this structure, we can show various specific data inside each cell. It could be useful for public interior to create some information art. For example, one cell could show some coloring temperature of some process. Another one could show some information about environment or some text information, and it could be connected with each other to form the human space into the natural way with such kind of digital technologies. The concept of such way of the parametric media installation in public space is growing from the ideas of digital architects, which are pioneers in generative architecture. Their message is when our space become complicated and our digital and urban environment becomes the same complicity like the natural space with modern instruments. So that's the parametric architecture directed to create some natural space inside the urban space. So this is maybe my final message I wanted here into the presentation, and very thank you for the attention. And
Eugen, thank you very much for this fantastic topic, because parametric design, parametric architecture, it's like algorithmic variant of algorithmic composition, but in architecture and design. So we are, as composer, you work with algorithmic composition in music, in sound, and also as designer, as architect, you work with algorithm in other space, physical space, and also media space, media environment. And I like it's very, very actual things. Your last idea to make a very natural physical object in very urban space, and I'm sure that for our project, like pandemic media space, you introduce in produce and propose a very big complex of new idea. And thank you very much for this lecture. And perhaps we have some questions. Please, questions for Jevhen.
Yes, for sure. Very welcome.
We can unmute no. Okay. If you don't have questions, so thank you very much for Ostap. Thank you very much for Evgeny.
It's okay. I think our today topics are really complicated. Me and Ostap, especially, we spoke about really complicated technologies. We just got understanding. So maybe people have to make some gap in time to understand this information, and maybe if there will be some questions in the future, we can make some answers.
Yes, of course. Thank you. Okay.
Thank you very much.
Thank you for all, and just I want to see this that our next lecture we have 21 November, and it will be a lecture of Polish artists. So please visit our Pandemic Media Space page in Facebook. Also, please use Pandemic Media Space site and try to compose your new work with date. Thank you. So see you later, and thank you very much for Ostap and for Evgeny for this. I'm very like your interview for Lisa Serenko and Klacker, and it was very delicate and profound way in your insight, in your experience, insight, or your imagination, and it's big велике щастя, що в Києві є такі артисти.
It's great. It's very good thing that in our city we have so much unique artists.
Thank you for you. So see you in Pandemic Space lecture.
See you.
Okay. Bye.